Welcome. This is going to be a series of videos that I'm shooting primarily for my AP Chem class, where I'm just going to do some problems and talk about kind of the methods of them. And I'm a little bit rusty. It's been a while since I've shot videos, so they might get better, they might not. We'll see how they go. Now, the first main problem that we're going to be seeing in AP Chem is called gravimetric analysis. And it's basically a stoichiometry problem where you're creating a precipitate, and a precipitate is a solid formed in the process of the chemical reaction. So generally in chemistry class, you dissolve things in water, and then when you combine two things that are dissolved in water and they form something that isn't soluble in water, it's going to precipitate out. And often that's, something that we're really looking for because that's what we can measure. And when you look at this problem, you're going to see that there is a precipitate formed, and there's really only one precipitate we can ever form. In any certain reaction. That's kind of how the problems are set up. And then we form that precipitate and we calculate off of that. So I'm going to read the problem through and chat a little bit about it, and then we'll do some work on it. So an unknown sample in the laboratory contains sodium chloride, NaCl, so they've given us a formula that makes this real easy. To determine the percentage of sodium chloride in the unknown, the sample was dissolved in 50 milliliters of distilled water. And so there you see that sodium chloride being dissolved in water, and I'm going to show you what happens when you dissolve that in water. The sample was then added to an excess of silver nitrate solution to form the precipitate. So basically, we kind of combined the salt solution, sodium chloride, with silver nitrate, and then from that we are supposed to form a precipitate, and we're going to filter that precipitate through filter paper. We're going to wash it with a little bit of that filtrate liquid that comes out, just to make sure that no impurities are sneaking in there in our precipitate, our nice solid. And then we're going to dry it out. So in sometimes they ask about, making sure adding to excess. To add something to excess, you always add until you can't see any more precipitate forming, and then you add a little bit more. Now in this case they've done it a different way, where they've added it to an excess silver nitrate. So basically they're pretty sure that we've got the whole precipitate out. So I'm working off of a chart, and you can see the chart if you're following along with the problems here. So the mass of my unknown sample is 1.453 grams. We're not going to do anything with that right off the bat. The mass of the dry filter paper, we are going to need that. And whenever you're doing this lab in class, you need to know what the mass of that filter paper is, because it's not part of the reaction. You need to be able to remove it. And then you get three numbers here: the mass of the precipitate and the filter paper. And you get a first drying, a second drying, and a third drying. And that's a pretty common question in AP Chemistry, is how do you know that you have your precipitate isolated, or you've sufficiently dried the precipitate? And the question is, how you answer that is you go until the mass doesn't change. And so when you look, the first number there, 3.565, that's, the precipitate, and it's kind of probably still wet, and it needs to be dried because water isn't part of what we're measuring. We need to get all that water out of there. And so we dry it, and it goes down to 3.081 grams. And so all that's been lost is just, that water is just dried out. And, you can heat it. You can just leave it to dry because, that water will evaporate on its own. You don't heat it over a Bunsen burner. You put it in a little oven, but that's beside the point. And then, when you get to that third one, it's 3.082, which is a little bit different, but it's gone up. And there's no reason why it would have done that. It's just basically the same between second and third. And that's how we know that, we're ready to do some math and that precipitate is prepared because, it's of a stable mass and, it's basically at 3.081. So my first question, we're going to go A through F. Write a balanced net ionic chemical equation for the formation of the precipitate above. And so what I'm going to do is I'm going to move my file down here. And so this is my salt and this is my silver nitrate. And then when you dissolve anything that's ionic, and these are ionic because they have metals, sodium and silver, so they come apart into their ions when you put them into solution. And so Na plus 1, chloride in its ion form, of course, is a -1. And, you can figure that out. Sodium is in that first column on the periodic table, which means it has 1 valence electron. Chloride has 7 valence electrons, which means it wants to gain 1 and become a -1. Silver is in that transition metal. You just kind of have to know it. And that nitrate is a -1. You kind of have to know that. Now, I'm not sure. I just put my question marks there. And so the sodium is going to be paired over here with the nitrate because positive here goes with the new negative, and then the positive, that silver, goes with the other negative, the chloride. Now, I have to decide what's going to be my precipitate, sodium nitrate or silver chloride. So I can tell you two things right here. One, silver chloride is a very, very, very common precipitate. And they've made it easy for us here because anything with sodium is going to be always soluble. So any sodium compounds is going to be generally very soluble in water. Any nitrate is going to be soluble in water. That's why we're having silver nitrate, because we can get that silver nitrate dissolved in water. And so obviously the precipitate, the solid that we're going to be measuring, is going to be silver chloride. And so you see here that on this end for a product, I draw that silver chloride together as a compound because it's no longer ions dissolved in water. It's going to be precipitate formed right there. And so you'll notice that the sodium is the same on both sides, the nitrate is the same on both sides, and so I can cross them out because they've done really nothing in the reaction. They haven't reacted. They've started in one form and they've ended in the same form. We call them spectator ions. And so we're going to get rid of our spectators, and then you have here that silver, who for some reason I started making an N. I don't know why, but that's an Ag plus that silver, and then there's your chloride ion forms silver chloride. So now I know that I have my net ionic equation, and the math that I'm going to be doing throughout the problem is going to be around silver chloride. So let's take a look and see what they want us to do next. Calculate the mass of the precipitate. Now, it'd be easy to just, look at that 3.082. I also use the third one. You're not going to get any difference between 3.081 and 3.082, so I just go with the last one. But we got to remember that we do have that precipitate on a piece of filter paper. And so what we're going to do is we're going to take in B the mass of that precipitate in filter paper, take away the filter paper, and you'll notice here that I get 2.220. Okay, and it is important that we put the 0 there, because for sig figs, when you're doing addition and subtraction, you always look to the places to the right of the decimal. So if I have 3 places to the right of the decimal here, and 3 places to the right of the decimal here, my answer should have 3 places to the right of the decimal, hence 2.22. Put that 0 in, keeps us reminded of our sig figs. So that's it. That's pretty easy. As long as we didn't screw up our sig figs, we're going to be all right on that one. C, calculate the moles of the precipitate. And so since we've determined that precipitate is silver chloride, I'm going to be adding that up to get 143. And this, just whatever your periodic table says, always keep whatever they have here. Don't worry about sig figs here, because this is a given piece of information, and just keep whatever you have there. And so I'm going to take my answer from here, because this is my grams of silver chloride. I'm going to switch it 1 mole of silver chloride that we've determined here is that 143 number, and that's going to get me 0.01549 moles of silver chloride. Now here I still keep, because that 0 is a placeholder, I have 1549, sorry, that is 4 sig figs right there. And if you get confused, you could write that as a scientific number, and it would be 1.549 times 10 to the negative 2, and that would indicate, oh, there's my 4 sig figs, and that shows how that first 0 is a placeholder. So I'm working now with 0.01549 moles of silver chloride. And I want to switch it to moles of sodium chloride. And so when I do that, I take the moles of silver. Now this is important, even though we know that it's kind of going to be a 1-to-1. You need to show that, and so you need to show that there's 1 mole of chloride in 1 mole of silver chloride that gets us out of there and into chloride ions, and then in 1 mole of sodium chloride, we do have 1 mole of chloride ions, and it doesn't change the number, but the whole point of doing gravimetric analysis and stoichiometry is to keep track of things. So you have to have those ratios set up, and you have to have them set up that way, because it shows you keeping track of that first silver chloride. You pull the chloride out, and then you put that chloride kind of back in to the NaCl to finish up. And so that was D. And then E is we're just going to kind of do the reverse and get the mass of the sodium chloride. And so I take that, and that's my NaCl, and that's moles. And then my mass is 58.442 grams. I just know that. I added it up. You could add it up, but I added it up so many times over the years, I just know it's 58.442 grams for table salt. And then that's going to be 1 mole. And then that's going to be 0.9025 or 0.9052. It's hard to read backwards. Grams of salt. And then I go all the way back to the very beginning, and I take my unknown sample. I take the part that I know is salt, that I've proved to myself through my work that is salt, and I take that, and put it over the unknown sample, and it's just kind of a percent. It is a percent. Times it by 100, and 62.30% for sig figs, and we're done.